All right, in this lesson, we are going to continue doing examples of the quadratic formula. But before we even do that, I need to show you some key skills that you need to have in order to do this well. Excuse me. So here's the first thing you need to know. If you are dividing something that is a binomial or a trinomial or anything that is separated by a plus or minus by a number, you are going to look at the coefficients. Because really what is happening is this 4x is being divided by 2 and the 8 is being divided by 2. Now, conveniently, both 4 and 8 are divisible by 2. So that's easy. 4 divided by 2, this becomes 2x plus 8 divided by 2 is 4. So it just becomes 2x plus 4. But if you have something that is like 4... let's say it was 2x, let's say it was different, right? 2x plus 8 over 4. Now 2 is not divisible by 4. But all three of these numbers can be divided by a common factor of 2. And that would make this a 1, this would become a 2, and this would become a 4. I just divided all these three by 2. And you would get 1x plus 4 over 2. And that would be simplified. Of course, you do not have to have that 1 there. So my point here is that you are going to divide by a common factor if the denominator doesn't divide evenly into both the numerator coefficients. Okay, let's look at a different one. What about this one? Does 3 go into both 3 and 2? Well, it goes into 3, but it doesn't go into 2. But do they have a common factor? Do 3, 3, and 2 have a common factor other than 1? No. So this is already simplified. If it can't be simplified further, then it's already simplified. What about these next two? So now this is a different kind of problem. Here's the thing that you need to know. If something is inside of a radical, you cannot divide this. These cannot be touched. It's like touching apples to oranges. You cannot do it. However, when a number is a coefficient outside of the radical, it is the same category. They're both apples. You can divide these two things right here because they are the same breed of number. When something is in a radical, it is a different breed. It cannot mate with it. So here I can do 4 divided by 2. And what's 4 divided by 2? Well, that becomes a 2. 2 over 1, and that 6 comes along for the ride. So this 2 is from the 4 over 2. Final answer. What about this one? Well, this one, I cannot do this. These are not the same breed. But I have to check, is the radical 18 simplifiable? Can I simplify it? Well, is there a perfect square that is a factor of 18? Yes. 9 times 2 is 18. Square root of 9 is 3 root 2. So this becomes 3 root 2 over 3. Now we have somebody who joined the team. It's no longer in the radical. It is free. So 3 over 3 is 1 root 2. And again, if you have a 1 coefficient, you do not need to write it. So it's just the same thing as saying square root of 2. All right, so now that we've done that, that's some housekeeping stuff. Let's do the quadratic formula. Here's a reminder of what it is. You should have it written down in your notes already. I'm not going to go over it. But the key here is that it has to be in standard form in order to even think about the quadratic formula. So example 1, what's the problem? First things first, what is the problem? It is not in standard form, so I need to do what in order to make it standard form? I'm going to add this 1 over here. So I get x squared plus 4x plus 1. This goes away, and what do I get? 0, because look, it has to be equal to 0. So that is good. We want this. Is equal to 0. So now we have it's in standard form, and I can identify my A, my B, and my C. What is A? A is 1. B is 4, C is 1. Notice how I already have this written down just to save time, so this is not a 20-minute long video. I have written down the quadratic formula with a bunch of blanks. So first things first is negative b. B is 4. So I'm going to write 4 here. Plus or minus the square root of b squared, 4 squared, minus 4a. C, a is 1. C is also 1. All over 2a, 1. Notice how it's all over. It is not just here, right? It is not just here. It is all over 2a. And then we simplify from there. So this we've already done. So I'm going to pause and come back. I want you to do this on your own. You should have gotten up until this point, right? Where you got 16 minus 4, and then you got the square root of 12. Now, is 12 a perfect square? No, 12 is not a perfect square. How do we know that 12 is not a perfect square? Well, nothing squared gives me 12. So I put this right here. Anything that is not a perfect square, if you take the square root of a non-perfect square, you get an irrational number. An irrational number is a number that is a decimal and it goes on forever. So like 2.6815 and there is no pattern to it. So something like 0.333 repeating is not irrational because there's a pattern to it. But numbers like pi are irrational. They go on forever. Okay? And in order to write those numbers down, you have to estimate them. So when we get something like this, we always want to keep it in exact form, meaning we want to keep the radical in there so that we can calculate it later on if we need to. Now, in order to simplify this, we need to simplify our radical, and we've learned how to do this. That is why we learned it. We learned that the square root of 12 we can simplify. Well, the square root of 12, what's the biggest perfect square that goes into 12? The biggest perfect square that goes into 12 is 4. So we have 4 times 3. This becomes 2 root 3. Square root of 4 is 2, and root 3 stays the same. So now we have x equals negative 4 plus or minus 2 root 3, right? This radical 12 just became 2 root 3, just from this, all over 2. And now we take what we learned in our do now, and we can simplify this. So, you see that plus or minus? That shows us that we can divide this 2, divide the negative 4 by 2, and we can divide this by 2. However, remember, we can't touch that radical. It doesn't get divided. So now I get negative 4 divided by 2 is negative 2, plus or minus. 2 divided by 2 is 1, root 3. And remember we said if a 1 is a coefficient, we don't need to write it. So this is the same thing as me saying negative 2 plus or minus the square root of. This is the exact solution because it has the radical. If I wanted to get the estimate, the approximate solution, I'm going to have to use a calculator and split this up, right? So I'm going to go like this. Actually, we're going to go like this. Boom and boom. And remember, when you have plus or minus, it becomes negative 2 plus root 3, negative 2 minus root 3. And this you just simply put into a calculator. And so if I put this into a calculator, I get negative 2 plus root 3, which is negative 0.267, actually 268 approximately. And minus is going to be negative 3.732. These right here are the approximate solutions. The only time that this is useful, The approximate is when we are graphing, because we need to know where to find my what. What does a quadratic formula help us find on the graph? The x-intercepts. So this would mean that my graph would look something like, let's actually go here, because we're in the negative x, 1, 2, 3, 4. Negative 3.72 is approximately there. Negative 0.2 is approximately there, and it's concave up. So it would look something like this, except I totally missed this point, but you got the point. So those are my x-intercepts. They're not as pretty, but those are my x-intercepts. We're going to do one more example in this video. So the reason that this one's good is because it's already in standard form. We got a is equal to -1, b is equal to -2, c is equal to 7. So now I'm just going to fill this in, and I'll be right back. We filled in all the blanks, and now we have a -2. What does a negative become? A negative becomes a positive. So that just becomes a 2. We have x equals 2, plus or minus. Now we have this big square root. -2 squared is 4, minus. Now, -4 times -1 times 7. Do one at a time. -4 times -1 is 4 times 7. 4 times 7 is 28. Positive 28. So now this is not a negative anymore. It's a positive 28. All over what? -2. 2 times -1 is -2. And then we simplify even further. Again, we always want to get this radical down first. So we have x equals 2 plus or minus 4 plus 28 is 32. All over -2. Now, we're going to simplify this, but let me make one thing very clear. If this cannot be simplified any further, that's your final answer. So for example, if I were to get something like x equals 5 plus or minus the square root of 3 all over 7. Or let's go 4, right? This can't be simplified. That is your answer. It's ugly. I know it's ugly, but we don't discriminate against ugly in this class. All problems are created equal. Now, the square root of 32 is the biggest perfect square that goes into 32 is 16 times 2. 16, square root of 16 is 4 root 2. And so this becomes x equals 2 plus or minus 4 root 2 all over -2. Now, these can both be divided by 2. I know it's like an ugly, I call it the heart method. That's the ugliest I've ever seen in my life, but it's okay. We don't discriminate against the ugly. So 2 divided by -2 is -1. Plus or minus 4 divided by -2 is -2, but you don't need to write a negative because this is already plus or minus. So we're just going to write it 2 root 2 because that -2 already exists here. And that is your final answer. That is the exact answer. And then if you wanted to find the approximate, you would put them into a calculator and you would do -1 plus 2 root 2, -1 minus 2 root 2, and you would get an approximate decimal. The approximate roots would be 1.828 and -3.828.